All right. Now, I hope, please raise your hand. I hope I'm successful. Do you understand what I mean when I say risk? Yeah? Nod at least. Nod. Yeah? Okay. Anyone? Yeah, I think you do. Okay. So now that we understand what is risk, how to reduce risk, now we'll talk about, so how do we decide? How do we decide what to do about risk? We use something we call the risk management framework. I'm trying to think of my favorite analogy for the risk management framework. I've written it a few times, but a framework, what do I mean by a framework? A framework is something that helps us organize things, right? So my favorite recent analogy, maybe this is a bad one, I don't know, but you can tell me after, is a radio, right? So my son, he's 13, and I've been trying to tell him, hey, go to school and explain to me how a radio works, because I can't figure it out. I'm just amazed by it. I still have not figured out that there's all of these electromagnetic waves traveling through the space around us, and somehow you turn on a radio, it can capture all of that noise, or no, silence, I guess, and turn it into something coherent that we can understand. That's what I mean when I say framework. So it's taking all of the information and things that maybe we can see it, or maybe we can't, maybe it's just hidden in the background, and it's funneling it through something so that at the other side we get something that we can understand, like a radio. So the risk management framework, this radio, it helps us make decisions. That's why we use it. We try to understand the problem and use that to make a decision. The steps that we follow in this framework, they need to be tailored to a specific problem. I said that already, but we'll say it over and over. Maybe it's one of our key messages. I don't even remember anymore. But there's no universal way to reduce risk. There's no universal problem. So every time you approach a new problem, you have to kind of develop a new justification for making a decision. And what we'll try to show you is what is a general framework to help you do that, recognizing that it's not going to be the same every time. Does that make sense? Yeah, makes sense. Okay. So this is a version of the framework that we use. As we were developing these slides between our team here, I think we debated, 12 different ways. And this is not the correct risk management framework. There's many versions. But it's one that we have used for this presentation to try to help you understand how the different pieces that we will discuss fit together. Okay? So, step one. The first part of the risk management framework is to define the problem and the objective. Maybe that's the most important step. That's where you begin. Step two is, once you've identified the problem and the objective, oftentimes, let's say you are the government of Nepal, and you say, wow, we have a lot of glacial lakes. How do we protect people from glacial lake outburst floods? If that's the case, often you begin by identifying the priority sites. What is the highest priority? Because you have to focus. You can't solve a problem like glacial lake outburst floods in Nepal all at once. There's no way, no matter how much money you had, you could never solve the problem like that. So you have to begin by prioritizing. So if you don't have a prioritization yet, then you start, so the question is, are priority sites identified? No, they're not identified. We have many sites across all of Nepal. We don't know where to begin. And you go here, and you begin with this regional prioritization, we call it. So taking all of the different sites that we have and helping us focus on the ones that we can actually do something about. That's step two. Now, if we've done the regional prioritization, then we can skip to picking specific sites and going to those specific sites to devise ways to reduce risk. That would be step three. Site-specific risk management design is step three. Then once we design something, we have to finish the detailed design, we have to build it, and then we have to maintain it. That would be step four, implement and maintain. If you're writing feverishly, furiously to get this down, we'll show this 57 more times in the next 2 days. Okay, so step three, site-specific risk management design. There's multiple steps within. Okay, so part one, identify the risks. So if you're at a specific site, you're at a debris flow site, you have to identify what the risks are. That's identifying what are the potential consequences and how likely is it to occur. That's the first step. And then next, after you understand what the risks, you try to identify what are my options? What are the lists of options to reduce risk? Right? That's step 2. Hopefully these 2 steps are familiar to you. It's what we just talked about in the last hour. And then the next piece, once you have an idea of what the risks are and the options for reducing the risks, the next step is to use tools to make decisions, like to compare the different options and decide which is the best, given the constraints. There was the great question about whether we should always build a house of bricks. This is where you decide whether it's reasonable to do that or not. And then the last step is once you have a decision generally, then you prepare a detailed design of whatever it is that you prefer. Okay? Maybe one last thing I'll say. So today I'm giving you an introduction. The introduction is just to give you the basic terms, the basic concepts, but all of the things that I'm describing today, we will come back to with case studies and examples. So today I'm not really presenting on an example that we've used. I'm just trying to give you familiarity with the terms. And then you'll see in the next presentations that Lauren will give, and Emily and myself tomorrow, that we're just going to focus in on specific aspects of this to give you examples of what we mean. So if you feel like at the end of this presentation, you feel like it's a little bit unclear, that's okay. It's okay to be unclear. We will come back to it and explain it in more detail. All right, so for the next 50 minutes, here's the agenda. We'll talk about those 4 steps. So those were the 4 steps in the big chart of our risk management framework. Step 1, define the problem. Step 2, I'll talk about regional prioritization, how we do that. Step 3, I'll talk quickly about site-specific design and the tools we use. And step 4, the implement and maintain. And again, it'll be a high-level overview that will provide more detail over the next few days. So we'll start with defining the problem. That's this part. That's what we'll do first. Step 1, defining the problem. So the first step, I think maybe everyone has heard this, right? The first step in solving a problem is to identify the problem, right? I spend a lot of time trying to solve problems that aren't real problems, actually. And then I'm like, wait, that's not even a problem. I need to focus, what is the problem? And then I can solve it. And let me just say that I have this problem in my career. I've made the mistake over and over and over again of solving the wrong problem, or not stopping to identify what the problem is. So I run off solving something without really understanding it. So the reason I have the picture of the trees is because let's say there's a disaster that occurs, and I'm a consultant, so I could be hired to go to the disaster, and I arrive there, and I'm asked to solve the problem, and I feel like I'm kind of lost in the forest. I don't know what to do, so I charge off in a direction. But it could be that I should have gone the other way, right? So you need to go slow at the beginning to identify the problem before you start to solve the problem. Similarly, the first step in making a decision is to identify the decision that needs to be made. Now, when I read this on the slide, all of you are like, yeah, that's obvious. But let me tell you, it is not obvious. My career is repeated I've made many mistakes in my career, and most often, it's because I'm not making the right decision, or I'm not, I'm doing something that's not the problem, or focused in the wrong way. So the question about the landslides, for example, it would be very easy if I have a community that's affected by something here. I could go and I could spend the rest of my life mapping the landslides that are in the Himalayas. And I could map the landslides, but it wouldn't be solving the problem. Right? So we need to focus on what is the problem and how can I solve the problem. So I'll give you an example. I've been working in Guatemala City for about 10 years. Guatemala City is a place where it's very interesting geologically. If you're a geologist, I recommend, maybe it's a good place to visit. So it's surrounded by volcanoes, and you have ash flows. Ash has filled the valley. And the valley is at the highest point in the continent. So it's actually at the continental divide. And it's a big flat plateau that's filled with ash. And there's rivers that come off in all directions. They get a lot of rainfall there. And in the country of Guatemala, there has been decades of war and decades of famine. So people from the countryside have been moving to the capital city because that's where they can find work and they can find education. Now, every flat piece of ground in the city has been taken up. So there's no flat places to be anymore. And so where people live now, when you move to the city, people move to the steep ravines that are on the sides. And I've been involved in a project to help manage risks in that place from landslides, because every time they get a heavy rain, they get small landslides that bury homes and kill people. And when I first arrived there, as I just said a moment ago, my first reaction was to map the landslides. I arrived, hey, we have to solve the landslide risk. Let's go map landslides. And we spent a long time, a year, mapping landslides. There's a million landslides. Landslides everywhere. And we came back and we said, hey, here's our map of the landslides. It's completely useless. All of the people, and now, maybe there's another case where it's not useless. So I'm not trying to say in general that's completely useless. But for my specific problem, it was useless to map the landslides. And the reason is that all of the landslides are in these neighborhoods of houses. All of the people there, they already know about the landslide. They don't need a map of the landslide. They won't look at the map of the landslide. It's completely irrelevant to them. What's relevant to these people is the fact that they have no government support. There's nobody coming to help. They have very limited resources, not much money to spend, and they needed to know, what can we do to reduce risk with our own small resources that we have? And so after a few years, we finally figured out that that was the problem to solve. And then it was actually very quick. Once we realized, oh, that's what we need to solve, then we can work with people who have experience here to come up with, well, these are things you can reduce risk. So I showed the example 20 minutes ago of moving the house. So we learned that most people who are killed in their bed when they're just below the slope. We said, oh, well, maybe the simple thing we can do is move the bed. Right? So solving the problem by understanding the problem is key. Now, the way that we get, so that's easy to say, and I told you I've made this mistake over and over in my career. So it actually, as part of making these slides, it kind of helped me in realize, what have I been doing wrong? Why am I always solving the wrong problem? And I think the reason is that I often start with a very imprecise definition of the problem or a very imprecise decision that I need to make. So for example, when I arrived in Guatemala City, the question was, how can we reduce landslide risk? Right? That's a very common, that's how you would expect every project to begin. How can we reduce landslide risk? That's what we want to solve. The problem with that is it's so imprecise that you can run off into the forest in any direction, but you don't actually advance to something that's useful. So now we've learned that when we begin a risk management project, we have to ask questions, and we have to define the decision that we're trying to make very precisely. So here's some of the questions that you can ask yourself or debate among your team. So one is, what is the hazard? So is it a very small landslide that's behind a house that you can manage just by moving a bed? Or is it the landslide the size of a mountain that's going to bury the whole village? Because of course, if it's going to bury the whole village, there's no point in moving the bed. Clearly, right? But if the hazard is small, in our case it was, these were small landslides. The size of a house would come down and bury 1/3 of the house. So we had to understand the hazard. Next, what is exposed? Right? So specifically, what is exposed? Well, in our case, it wasn't concrete buildings. It was very, very fragile buildings, like the straw buildings. So if a landslide came, it would be destroyed. And we knew that there were no options available. People did not have money, to the question that was asked before. There was no money available to build concrete buildings. You had to build with inexpensive materials. So therefore, it wasn't possible to just build a stronger building. You had to find other ways to reduce risk. What is the key consequence? In this case, it was life loss that we were interested in. And then what are the options? What are things that we could do? It's important to know all these things before you write down precisely what you're trying to solve or what decision you're trying to make. So in this case, we took, initially in Guatemala City, we said, how can we reduce landslide risk? And we made it more precise. And we said, how can individual people who live there, how can they protect themselves with their own resources and without the support of the government from being injured or killed by small landslides that affect their homes? So you see, when you define it very precisely like this, suddenly you're starting to understand the direction to head, to get out of the forest and to solve the problem. Does that make sense? And this might be like, again, it might be the key to the whole thing from my experience. So if you were to, I think we'll give the slides out later, right? Okay. So if you wanted to have a cheat, we call it a cheat sheet, like a short list of when you start a new project, these are the questions I ask myself to make a precise definition. This is going to be the cheat sheet. So we have here a list. You won't be able to read it really now, but I'll read it to you. So the first step is, what is the problem? So be precise. What is the problem I'm trying to solve? In this case, it was small landslides. They're killing people in their homes, and there's no funding available to stabilize the slopes. That's the problem I'm trying to solve. What are the objectives that I'm trying to achieve? I'm trying to provide options for people to reduce the risk that they face, and I'm trying to provide training to people so that they understand what the options are. The next thing you can ask yourself is, what is the decision that needs to be made? In this case, it was, how can individual people protect themselves with their own resources from being injured or killed? And then I'll say, oftentimes when you do it this way, you come up with a very big problem that seems impossible. Like, wow, we have glacial lake outburst floods affecting large portions of our country. It's overwhelming to think about. And in that case, you need to break this large and complicated problem into smaller pieces and attack each of those pieces one at a time. So the key message, a detailed problem statement sets the project direction. This is you must do this, you cannot skip this step. All right, step 2, I'll move into regional prioritization. So in our framework, we talked about defining the problem. Sometimes you won't, if it's a big problem that impacts many different locations, and you don't know which to focus on, you'll do the step of regional prioritization. That's what we'll talk about now. And then I think Lauren will speak quite a bit more about that afterwards. So risk management, when I say risk management, this is this whole process of making decisions about risks. Well, it happens at 2 scales. So the first part of that scale is prioritizing, deciding if you have limited resources, where will you spend those resources? If you have limited time, where will you spend that limited time? That's the prioritization step. Then once you prioritize, then you can select individual sites that you focus on those individual sites for reducing risk. You can't really, when you say you want to reduce risks from glacial ice outburst floods to the country of Nepal, you can't do that all at once. You have to do that individual site by individual site. And the first part is deciding which individual site will you begin with. And we use prioritization, so it's not just, it's not like just a step you have to do. It's actually useful. You can get from it, you can select the sites where you're going to focus for risk reduction. You can use it also for setting budgets. So if you're the government of Nepal, you can do this prioritization to understand what is the size, the total scale of the risk, how much would it cost to mitigate, and you can begin to plan for allocating resources to the different sites. Okay, so for the rest of this presentation, I'm going to run through really many different methods. We call them methods. So think of this like you have a toolbox. In the toolbox, you might have a screwdriver. You might have a hammer. You might have a wrench. There's a joke about if you only have a hammer, everything looks like a nail. Have you heard that joke before? If you only have a hammer, then it doesn't matter what the problem is, I'm going to beat it with my hammer. So consider this a hammer, right? This will work in a specific setting, but it doesn't work everywhere. You have to choose the right tool for the right problem, the right thing you're trying to do. And so this hammer is something that tends to work quite well for prioritization. We call this the risk index method. There's probably other names, but when I say risk index method, what I'm describing is a method that allows me to assign a value, because when you're prioritizing, you might have 100 sites, and you're trying to understand which of the 100 sites to focus on. So you need to rank them, like from 1 to 100 in some way. And for that, you often need to have a very precise number, but that number is usually developed based on relatively little information. because you can't do a detailed study at all of the 100 sites. So you have to take something where you have very little information, but a precise way to rank the different sites. And this risk index works for that very well. You'll see many examples in the literature of this, where you can take the three components, hazard, exposure, and vulnerability, and you can give each of these a score ranging from 0 to 1. So let's say the hazard for, let's say a given building or a given site is 0.3, the exposure is 0.9, the vulnerability is 0.9 for this example. If you multiply them together, you get this value. And you see that you can do that at every site and then compare them very precisely. So if that doesn't make sense, don't worry, we'll come back to it. But the reason I'm introducing that is because I'm going to use that just now to explain an example. So imagine you have a road. Here's a place, and here's a town, there's another town, and there's two roads, two ways that you can reach it. And you have these different sites, A, B, C, D, E, F, G. Each of these sites is affected by a hazard, a rockfall or a landslide, some type of landslide. And you can do something to assess the risk at each site. So like I said, you can take the size of the hazard and give it a value. You can take the exposure, like how much traffic comes there, give it a value. The vulnerability, like how likely is it to be destroyed if it's hit. You can multiply those together. And then let's imagine. I know you can't see it very well, but it's really not that important. The point is, if you multiply those values together, you can get a risk index that, say, varies from 0.9 to 0.2. And you can put those sites in order, from the highest risk to the lowest risk. And that's what this is showing. So highest risk to lowest risk. And then you could do an assessment of saying, okay, how much would it cost to reduce the risk here? And you can do a high-level study to understand the mitigation cost. This is how much it costs to, say, install a mesh to protect against the rockfall, or to install a larger bridge so that the debris can go below the bridge. So that's the costs. And then if you take the risk reduction, so this is like the amounts that's reduced, so when you have an initial risk and you mitigate it, so you reduce that risk. You take that risk reduction and you divide by the cost, you get something we call a benefit-cost ratio. This is telling you something that's most cost-effective to implement. So those are the three columns that I'll keep showing you in the next couple of slides. Now, if you rank things by the highest risk, well, that can be useful for some decisions. You can use that for disaster preparedness. This is telling you where you're likely to have the largest losses and where do you need to do something like stage equipment or educate people or raise awareness. That's what we would use the highest risk prioritization for. We rank from highest risk to lowest risk. Okay, another way that you could rank it, you have the same sites. Well, rather than ranking it from the highest risk to lowest risk, you could rank it based on the benefit-cost ratio. So this is in terms of cost effectiveness. You say, okay, well, although it's not the highest risk site, I could spend the least amount of money to fix it. So if I don't have much money, the best place to go is the most cost-effective site. That's the place to invest first. And this is great when you're trying to decide where to allocate resources, and also what is the maximum risk reduction that you can achieve for some available funds. So let's say you have $100. This is where you can spend it most effectively. So let's imagine that the highest cost effectiveness, the ones where you spend the least amount of money for the greatest return on your investment, are each of these sites that have the green check marks, A, B, F, and G. That's what this showed, right? A, B, G, F. Those are the ones that are the highest cost effectiveness. Well, if those are distributed across the two roads, you may find that still an event happens, you spend money here to reduce risk, and still the road is closed when an event happens, right? Because these sites were not protected. So this, if you wanted to drive to there, you can't make it because the road is closed. You want to drive this way, you can't make it because the road is closed. So another way to prioritize is based on corridor. We call it by corridor. So it's saying rather than look at the sites individually, we would look at the whole length of the road. And we want to bring the road, every point along the road, to the same level. So that we don't want to spend, say, all of our money at one site, because it's like a chain. The road is a chain. If you spend all of your money on one site, then you can have a very small storm that closes the road at a different site. So you just bring all of the sites up to the same level. And in this case, this corridor might, although it only has 3 sites, it might cost 13 million or whatever the value is, some large number. Whereas for this that has 4 sites, it costs less to protect the entire corridor. So if you wanted to have a road that is resilient to hazards, maybe the best investment would be to protect these 4 sites to allow this road to be open and allow that this road here could be closed. This is the type of logic and the type of analysis that we do when we're at the prioritization step. Yeah. Questions? Now is a good time for questions. I think now it's getting a bit hot and everyone's getting more tired too. So, including me. No questions? Yeah, go ahead.
Sorry, I want to go back before.
Yep.
So, you are talking about doing this risk reduction, and there's these equations and these different components. And in social science vulnerability, this is what I was trying to understand, is like vulnerability also speaks to the capacity
Yes.
that communities have. And your example in Guatemala was really talking about capacity that comes into the decision making. Right?
Yes.
What do people do with using their resources? So how does that fit? How does that capacity piece, that human vulnerability piece, fit into this?
It still fits into the vulnerability place. So we do things like we would include a modifier for social vulnerability and the ability to recover after an event. So when we speak of vulnerability, it is like over the course of a disaster, what is the proportion that is lost or the probability of loss? And that can be related only to the physical aspects, like the construction of a home, but it can also be related to a person's behavior, their ability to recover after an event, if we're talking about, say, business interruption or other things. So we are using it holistically, I guess, meaning many different things.
So so you could use economic data that looks at
Yes.
regional capacity, individual capacity, and that would go into the vulnerability.
Yes. Yes.
Okay.
Or the scope definition, yes. Or the consequence, yeah.
Okay.
But the consequence comes from the combination of the hazard, exposure, and vulnerability. So all kinds comes out of it. It's what happens when you combine those things. Any other questions? Move on. And I have just time check, I forget when I was supposed to stop. 20 minutes.
Goes to 45, right?
Okay, the next part is step 3. So after you prioritize, the next step would be a site-specific design. So you choose one site, and now you go there and you try to do something to reduce risk at that site. So the key point is that risk reduction, so the prioritization step just helps you decide where to focus, helps you decide what to spend your time and money on. But risk reduction, it doesn't happen at the regional scale. Risk reduction happens at the site-specific scale. That's where you go to a place, you solve a problem for that place to reduce the risk. Not sure what happened to the image, but you get the point. So the key message, risk reduction happens at the site-specific scale. So if the question is, how can we reduce the risk from glacial lake outburst floods in the country of Nepal? Well, one answer is we need to begin by solving it at individual lakes, for individual communities and individual places. That's how you have to begin. I introduced this already. There's basically 4 steps. The first is to identify the risk. The next is to identify the risk reduction options. The next is to use decision tools and select and refine the alternative that we choose. And then the last is to design it in detail. And I'll start by talking about the decision tools that we use. And before I get into the decision tools, this is a bit of a tangent. So I just want to make a point before we talk about the specific tools. And that's that whenever we're making risk reduction decisions, and this was, again, the point was raised or asked earlier about building, do we need to build all of our buildings out of reinforced concrete? We don't have the funding for that. Well, that's what I'm trying to say here, is that we can't, right? We always have to seek balance when we're making a risk reduction decision. And there's often many different things that we're trying to balance, but often we're trying to balance these three things. One is, what is the risk itself? With how much risk are we willing to tolerate? With what risk control options do we have available to us? So I'll give you an example of this. So everyone close your eyes. Okay, remember 2020 when it was COVID times. Yeah? In COVID times, at some point there was a lockdown, but after the lockdown ended, you were able to go out and do business and go to school. And every day, you can open your eyes now, maybe, but every day you had to make a choice. And I don't know, maybe it was different in Nepal and Bhutan, but where I lived, this was my choice. I could choose to wear a cloth mask, or I could choose to wear what we called an N95 mask, more like a medical mask, or I could choose to wear this like full-on suit, right? I had those choices. Now, I could use the cloth mask. Maybe it didn't have a very large benefit, but it also had a small benefit, but a small cost. I could wear this mask, which had a higher benefit, but it cost a lot more. And by cost, I meant it was hard to breathe and it tried to cut off my ears. I didn't like it. And then this one, at the beginning it wasn't even available, but when it became available towards the end, this has the greatest benefit. It's clearly safer than those others, but I didn't ever use this, right? Because the cost was too high. So this is the point that you're trying to balance, make a decision. Which of these should I wear? This is an example, but this could be a glacier lake outburst flood risk, right? Which of the methods should I choose to reduce the risk? And the point I want to make is that there's kind of three categories that you're often trying to balance. So the first category is the risk estimate. This is like, how high is the risk? And so I would try to ask myself, well, how old am I? If I'm young, then my risk is fairly low. So maybe I could tolerate higher risk. Or maybe if I'm young, I might use the cloth mask because I know that my risk is low because I'm young. But if I'm young and I'm immunocompromised, I'm sick, then maybe the risk is too high. I shouldn't wear the cloth mask. And also, maybe I'm young and I'm healthy, but I'm going to visit a COVID ward where I know that there's lots of people with COVID. Then now I know that my risk is high. And that might affect what type of mitigation or protection that I use. Right? So that's the risk value. That's one part of the thing I'm trying to balance. Another thing I'm trying to balance is the risk tolerance. And when I say risk tolerance, that's like how much risk I'm willing to accept. So I like to play soccer. And during the COVID pandemic, my soccer games continued, but we had to wear masks. We were asked to wear masks. And I tried to wear the N95 mask and it was impossible to play because I couldn't breathe enough to play. And so I had to make a decision. Will I continue playing soccer and use the cloth mask, or will I stop playing soccer? And I decided that my mental health was important enough that I was going to play soccer without a mask. And that was great until I got COVID and gave it to my whole family. Right? My wife was still not happy about that. But I was willing to tolerate a quite high level of risk because I wanted to play soccer. That was helpful for me to be able to go out and run. But I can promise you that if I had had a friend who had recently died of COVID, if I had a friend that had recently died of COVID, or if I really thought about the fact that I could have killed somebody in my family, I would not have tolerated that risk. Right? So your risk tolerance can change with time, and it can change based on what's happening. And then the last piece is the risk control factors. These are the other things that can affect like which type of mask I would wear. So, for example, at the beginning of the pandemic, I didn't have the vaccine. So in that case, maybe I would adjust my risk tolerance and I'd say, I don't have the vaccine, so I'm going to wear the N95 mask, even though it cuts off my ears, because I don't want it, because I don't have the vaccine. But then after I have the vaccine, I would say, I'm fine wearing the cloth mask, because even if I get the virus, I'll be safe because I've already been vaccinated. So when you're making a decision about risk, you always have to seek balance, and these three factors can be helpful to think about how to balance them when you're making a decision. That wasn't clear at all, but I don't know how to improve it, so I'll move on. Now, I don't want you to copy this down. I just want you to know that it exists. It's in the slide deck, but this is sort of a flow chart that we've started to use to try to seek this balance. So these parts here, these all relate to the risk estimate. So we have a hazard model, an exposure model, a vulnerability model. We bring them together to get a risk estimate. When we want to investigate what is our risk tolerance, we begin by understanding what are the benefits of taking the risk. And then we think about all the different conditions we could apply for tolerating the risk. And then for risk controls, we think first about what are our constraints. What budget do we have available? What land tenure do we have? What are the political priorities? And then we use that to identify what would be feasible to apply. And based on these three factors, we kind of balance them. We say, what's the best thing to apply in this location? Does that make sense? Are there any questions there before I move on? Yes, go ahead.
I'd like to see the question this time, I guess. Do we face any specific scenario where cost-effective methods should be prioritized over the higher risk place? Because I'm thinking like this, as it's a matter of solving the problem, not the matter of investment. Why not to go place with higher risk even if we have?
Yeah. Okay. Okay, the question was, why wouldn't you always, I'm not sure that, I'm trying to show you something, but I can't find the right thing, so I'll just try to speak. Why would you not always prioritize from highest risk to lowest risk? Yeah? One reason is that, let's say that this is the highest risk, A is the highest, B, G, F, these are the highest risk. Well, if you prioritize based on these, then, and you design something to protect from these, well, then your road is still closed because you didn't try to protect this one. Even though you spent lots of money here, the road is still closed because this site fails during the storm. So when you design only by the highest risk or prioritize only by the highest risk, that's good for understanding the problem. It's good to know where the highest risks are, because you can use that to make decisions about like where to stage resources. You can use that for educating people. You can use that for awareness, to say these are where the high risks are. But most of the time, that's not the best way to prioritize. Most of the time, you have to think about what objective are you trying to achieve. So if your objective is to keep the road open, then I'm not going to choose which side of the road to repair based on where the highest risk is. I'm going to decide which side of the road to repair based on which one will cost the less to fix. So if these are the high-risk sites here, I could pay 13 to mitigate them, and I would manage the high risk. Or I could spend 6. I could spend half as much to mitigate these sites that were low risk, and I would still be able to connect my two communities. Does that make sense? Okay. Time check? 10 minutes. 10 minutes, okay. So this next part, manage risk by balancing competing objectives. That's what we want to do. We want to balance all of these things, find the balance. As I said, there's a toolbox, right? There's many different tools that we have for comparing the risks and for estimating the risks. And it's important, don't think that because we gave one example of one method that you should apply it everywhere. It doesn't work that way. When you have a hammer, it's great if you have a nail, but if you have a screw, you need a screwdriver. So what we're hoping to do here is we'll give you some examples of how we have applied these different tools so that you have an idea that they exist, so that you know where to begin, but you're not going to be able just to apply it directly. So some examples I'll talk about are risk assessment methods. These are ways that we understand and describe the risk. And then other decision tools, these are ways that we compare the different options for reducing risk. Good to go past that, I think. So I'm going to run through, I'm just going to show you the different tools. This one's the hammer. The next we'll do the screwdriver. Okay? The first one being the hammer is a risk matrix. So this is a risk matrix. The y-axis here is probability. So this is how likely is the landslide to occur and cause some consequence. And then the x here is a description of the consequence. So low consequence to high consequence. And we can plot onto this matrix very quickly what the risk is at different sites. And this is great for sites where we have very limited data. It's very quick. We can understand very quickly which category we are in, and we can assign a value. And it's also very easy to explain to somebody else. Why did you call that high risk? Oh, well, I called it high risk because we have a probability greater than 10% per year and large damage but not complete destruction. So it's a great communications tool. So that's one tool, that's the hammer. Now we're on to the screwdriver. The screwdriver would be a risk tree. And again, if you feel a little lost because I'm running through these quickly, it's okay because we'll come back and show more examples. I just want you to have a general sense of what exists in the world. A risk tree. So the risk tree is, we start with an event. This case could be a heavy rainstorm that triggers it. That can initiate a debris flow. And once the debris flow is initiated, you can either have the debris flow not reach the house, or maybe it flows and reaches the house. And then once it reaches the house, it could cause loss, or it could be so small that it doesn't damage the house. So this is a way of like organizing your thinking about the steps that need to happen in order for the risk to happen. Now, this is a great tool for visualizing the steps that then you use for quantitative risk assessment. Because when you quantify risks, you basically multiply the probability of each of these steps occurring. So it's important for that. The other thing is that every one of these steps is an opportunity to end the chain. Right? You have this chain of events that's causing some loss. Well, if we say there's a debris flow that initiates, we don't want it to reach the house, here's a place that we could build a barrier that keeps it from reaching the house. So every point here is a way that you can reduce risk. It's another way of developing options. Quantitative risk assessment. If we do a quantitative risk assessment, you can do this for economics, so you can quantify the cost, or you can quantify the probability of death, for example. And the way you do it, you start with that risk tree, and as I said, you multiply the things together, and you'll recognize these terms. So the first term is the hazard. So what is the probability that the landslide begins? That's where you begin. Then that term we multiply by the spatial probability. So given that it begins, what is the probability that it runs out far enough to hit the house? That's S. And we could have temporal probability. So given that it hits the house, what is the probability that a person is in the house? So that's how much time do they spend in the house? And then the last is the vulnerability. So given that the person is hit, how likely are they to be killed? We multiply those things together, we can quantify the risk. When we quantify it, it could be something like the probability of death is 1 in 10,000, or 1 in 100 risk that this person could be killed. Now this is really helpful. For example, if you have a landslide site and a rockfall site and say an industrial factory, and you want to compare the risk from the industrial factory to the landslide, that's hard to do if you're just comparing it based on a matrix or other things. But if you quantify the risk and you say, well, your risk of dying in a landslide is 1 in 1,000, and your risk of dying in a car accident is 1 in 10,000, and you can say, well, the landslide risk is much higher than the car accident risk. And now you start to understand what that risk means, and you can describe that to somebody, and you can use that for making decisions. A really common way that we use this in Western Canada is we quantify the risks so that we can make the decision of, are people safe enough? And we use the car accident as the background. We say, well, we want the risk of death at a house to be at least lower than the risk of death in a car accident. And we can do that by quantifying both types of risk. So for example, this is this number line here. On the left, 1 in 1 million risk of death, we would consider that pretty safe. And on this side, we have a 1 in 1 risk of death, that's certain death, in a given year, say over the next year. And we often define a threshold here at about 1 in 10,000. We say if the risk is less than that, it's safe enough to live there. But if the risk is more, then we need to do something to mitigate the risk. Now, I'm not saying that the 1 in 10,000 should be used everywhere, probably nowhere, but it's just an example that you can put a line somewhere here and define it as your threshold that you use to make this decision of whether something is safe enough or not. You can also do the same risk assessment, that was for life loss, but you can do it for economic risk as well. So you follow the same tree, hazard, spatial, temporal, but now we're not talking about a person, maybe we're talking about a house or a neighborhood or a community. And that exposure could be something like, what is the value of all of those homes? And you can, take the same equation, multiply it by the initial amount that was exposed, and get a risk, which is like the amount that could be lost in a year. And you use that then to decide how much you would invest in risk reduction. So you can use this economic risk to decide how much to invest. So for example, here's a site in Western Canada where you have a risk of, say, $30 million. So every 30 years they could have a big debris flood that buries the highway. Or sorry, every 50 years. And that would cause $30 million in loss. And the $30 million in loss is because all of these trucks that are here are carrying goods that can't get through. Yeah? So you can quantify it in this way, and then you can use that to decide what it would be cost effective. So you know right away that if the risk is only 30 million every 50 years, you shouldn't be investing more than that in the risk reduction. That would be unreasonable. You don't want to invest more than what the risk is. So this is why you would quantify risk. Okay, so those were methods for quantifying risk. Now I'm speaking of methods for making decisions by comparing different things that you want to balance. We have a method we call a multi-criteria decision matrix. It's a really good way to compare options. And the way it works is on the rows in the column, each is something we care about. So one is a cost. Another thing would be how much risk is reduced. It could be how easy or difficult construction is. So these are all things we care about. And then here are the different options that we're comparing. And you might find that, for example, like this one here is just too expensive, right? The cost of it is $31 million, so you can't afford it. So it doesn't matter what these other things are. It's canceled out. But now you still have to compare these two, and you'll find that, almost always, you'll find that, well, this option is better in some categories, this option is better in others, and you can use this for describing this to other people, and also justifying the decision that you make, and for exploring this decision yourself. All right, I'm going to move on now to step 4, which is after you've made some site-specific decisions, now you're implementing and maintaining a design. So I'm almost done. I have like just 3 or 4 slides, and these ones are less, like the last one was running through tools and everyone's bored, I know. It's okay, I understand. This part I want you to listen to. This part is like, these are like key things that I've learned in my career from doing it wrong for a long time. So this one, this is something that we often forget, but I want everyone to remember this, and that's that operations and maintenance requirements, they're determined during the detailed design. I've seen in a lot of projects where there's this tendency for the designer to design something, and then they disappear, and then a different company comes along to design the operations and maintenance plan. That just doesn't work. It does not work. And the reason is because when you're creating the design, that determines what the operations and maintenance is. And when you're comparing options, there's always a trade-off between the capital costs and the capital things you build at the beginning versus the operations and maintenance. So for example, this design, this is a debris flow barrier in Southern California in the United States. This one has, debris comes in and it fills the basin. Well, the only way for this structure to work in the long term is there has to be a maintenance budget to clean out the basin. If you build this and you don't create a budget for cleaning the basin, it won't work, right? Because the first event that happens, 5 years later, it's filled. And now you've wasted all of this money because you didn't plan for the operations and maintenance. So you must do the design of the structure with the operations and maintenance. Similarly, the disaster response protocols, they are determined during the detailed design. Just like the operations and maintenance is, so is the disaster response. So for example, if you have a water supply intake, so first off, this is not a gate. It doesn't go up and down, it just is there. I don't actually know what that is, but it doesn't go up and down. It's just an open hole. So if the design does not include a gate, and it's not possible to lower a gate, it doesn't make any sense to design a disaster response that says, oh, we're going to install an early warning system, and when the alarm goes off, we're going to lower the gate. If there's no gate, you can't lower the gate, right? So you must think about the disaster response while you're doing the detailed design. All of these things have to be integrated. And I think there's most of the failures that are occurring with our infrastructure is because we are not thinking about disaster response during the design, or we're not thinking about operations and maintenance during design. So we have to bring that whole process together and start looking at infrastructure in terms of a full life cycle. I'm almost done. How much time? Yeah. Okay. So it's always a trade-off, right? So for this type of design, it might have a very large capital cost, but a very low operations and maintenance. This one could be the opposite. A small capital, higher operations and maintenance. And sometimes you might choose this because it has the lowest cost overall. Sometimes you'll choose this one because we don't have much money for construction, but we're willing to pay for the maintenance in the long term. But just recognize this. So key messages are that a detailed problem statement sets the project direction. So an hour ago I spoke of that. Don't skip that step. It's an important step. I gave you some ideas for how to take an imprecise decision like how can we reduce landslide risk and turn it into something very precise and actionable. This is a key step to helping you go onto the right path. The next key message was that risk reduction happens at the site-specific scale. So you can't solve the glacial lake outburst flood problem for all of Nepal. You have to do it at each community or each piece of infrastructure. And the last key message that I've pulled out somewhat arbitrarily from the many other key messages, is that we manage risk by balancing competing objectives. You always have to find a balance. You can't just go for the most expensive or go for the best or whatever. You have to consider what do we have available, what is the risk, how much am I willing to tolerate, and make a holistic decision. So I hope maybe this image can be burned in your mind. It doesn't really matter what the words there are, honestly. It's just we're looking for balance. That's what we're trying to do. And we do have resources. Most of the information in this presentation has come from recent publications that we will make available to you somehow, I think. I don't know who's here, but I'm looking for Mandeep or Rajan or somebody. But we can make these available to you. And thank you for your time.